Hello again everyone, this is group 1. Today we are going to discuss about chapter 3 subtopic 3.1 Newton's Universal Laws of Gravitational. Gravitational force is known as universal force because it acts between any two bodies in the universe. It is directly proportional to the product of the mass of the two bodies, that F is proportional to m1 and m2. At the same time, it is inversely proportional to the square of the distance between the center of the two bodies. That is, F is proportional to 1 over r squared. The two relations above are formulated to obtain Newton's universal laws of gravitational. F is proportional to m1 m2 over r squared. Newton's universal law of gravitational can be expressed as follows. F1 equals to F2 equals to g m1 m2 over r squared. F1 equals to F2 because both bodies experience same gravitational force since F is proportional to m1 m2. From the formula, F is gravitational force between two bodies. m1 is the mass of the first body while m2 is the mass of the second body. R is the distance between the center of the first body and second body. G is gravitational constant and is 6.67 times 10 powers minus 11 Newton meter square per kilogram squared. Here is the way to calculate the gravitational force between two bodies. To calculate the magnitude of gravitational force, there are two things that need to be obtained. Number 1, mass of the two bodies, and number 2, distance between the center of the two bodies. Once you get the values of the above, follow the 3 steps here. Step 1, list the given information in symbol. Step 2, identify and write down the formula used. Step 3, substitute numerical values into the formula and perform the calculation. Here is the example. Calculate the gravitational force between a durian and the Earth. The mass of durian and the Earth are given and the distance between the center of the two bodies are also given. So, step 1, list all the given information in symbol 2. Step 2, identify and write down the formula used. The formula for gravitational force is F equals to g m1 m2 over r squared. Step 3, substitute numerical values into the formula and perform the calculation. F equals to gravitational constant times mass of durian times mass of the Earth divided by the square of the distance between center of the two bodies. After the calculation is done, you will get 19.63 Newton as the answer. Here is another example. A worker in construction site accidentally drops a brick. The brick experiences 20 Newton. What is the mass of the bricks? All the information is given, but there is a difference between this question and the first one. The question gives us the gravitational force that the bricks experience instead of the mass of brick. Even so, the solution is still the same. Follow the 3 steps and get the answer. So the mass of the bricks is 2.04 kg. Now let's talk about the effect of mass and distance between two objects on gravitational force. The diagram on the left shows that a larger bodies have greater gravitational force. Therefore, the larger the mass of the body, the greater the gravitational force. The diagram on the right shows that the body which has longer distance will have smaller gravitational force. Therefore, the longer the distance between the center of the two bodies, the smaller the gravitational force.
Let's discuss the relationship between gravitational acceleration g on the surface on the Earth and universal gravitational constant g. From Newton's second law of motion, gravitational force can be expressed as F equals mg while F equals ma when gravitational force is not involved. From Newton's universal law of gravitational force can be expressed as F equals g m1 m2 over r squared. Value G is directly proportional to the distance from the center of the Earth for lowercase r smaller than uppercase R. Value G is inversely proportional to the square of the distance from the center of the Earth for lowercase r greater than or equal to uppercase R. Hence, gravitational force is expressed as G equal mgm over r squared. By the way, the lowercase r means the distance between the centers of the two bodies, while the uppercase R means the radius of the Earth. For example, mass of the Earth is 5.97 times 10 power 24 kg and the radius of the Earth is 6.37 times 10 power 6 m. Calculate the gravitational acceleration on the surface of the Earth. Same as the previous questions. List the mass of the Earth, gravitational constants and radius of the Earth. Then determine the formula that is needed. For this question, G equals gm over r squared is used since we need to calculate gravitational acceleration. Finally, do the calculation and the answer is 9.81 meter per second. Another example for gravitational acceleration, a satellite is orbiting the Earth at an altitude of 560 km. What is its gravitational acceleration at this position? Same as usual. List the given information, which is gravitational constant, mass of the Earth and radius of the Earth. There is an important thing you need to remember. 560 km must be converted to meter. After that, you can start to do the calculation. When you have done the calculation, you will get 8.29 meter per second squared as answer for this question. For a body in circular motion, a force acts on the body in a direction towards the center of the circle. The force is known as centripetal force. The formula used to calculate centripetal force is F equals mv squared over r, where F is centripetal force, m is mass, v is linear speed, and r is radius of circle. Here are some notes. When a body is rotating at a certain uniform speed with the string almost horizontal, the effect of gravitational force can be ignored. So the speed is uniform, the direction of the body keeps changing. Linear speed shows how fast a body moves in a circular motion. For example, a hammer-throw athlete swinging an iron ball with mass of 7.8 kg in a horizontal circle before releasing it. The length of the string is 1.8 meter. What is the centripetal force that acts on the iron ball when the iron ball is moving at a speed of 20 meters per second? Step 1. List the information given. R equals 1.8 meter as the athlete is the center of circle, so the length of string becomes the radius of the circle. Then use the formula F equals mv squared over r to calculate centripetal force. You will get 1600 N as your answer for the question.
Is the simulation of projection of Isaac Newton. Imagine that you are standing on the top of a very high mountain with a cannon. Cannonballs are then fired with increasing velocity. There are three situations. First, cannonballs fire with low linear speed, 3,000, 5,000, and 7,000 meters per second. We follow trajectories A, B, and C, respectively, and eventually hit the ground. Cannonballs fire with sufficiently high linear speed, which is 8,000 meters per second, will follow trajectory D and orbit the Earth in a circle. As long as external force do not slow down the cannonballs, that they orbit the Earth perpetually. Object that move because of the gravity alone is said to be free falling. Number third, if there were no gravity, the cannonballs would follow path E, which is a straight line, and leave the Earth. Now, we are going to talk about centripetal acceleration by comparing the formula for force F equals to ma and formula for centripetal force F equals to mv squared over r. We obtain the formula for centripetal acceleration. A is equals to v squared over r, where v is linear speed and force of satellites, and r is the radius of the orbits of satellite. Here is an example. A weather satellite is orbiting the Earth at a height h equals to 480 km. Linear speed of the satellite is 7.62 multiplied by 10 power 3 meters per second. The radius of the Earth r is 6.37 times 10 power 6 meters. What is the centripetal acceleration of the satellite? Step 1. List the information given and remember to always convert the unit kilometer to meters. Step 2. Use the formula A equals to v squared over r to calculate centripetal force. Finally, you will get A equals to 8.48 meters per second squared. The mass of the Earth and the Sun can be derived by using the formula of Newton's Universal Law of Gravitation and the formula for centripetal force. First, equate the two equations. Next, cancel 1m and 1r, which are common factors. Then, substitute v by 2 pi r over t, where r is the radius and t is time. Finally, we arrange so that m becomes the subject of the formula. So the formula for mass of the Earth and the Sun is 4 pi squared r cubed over gt squared. Here is an example to calculate the mass of the Sun. The Earth revolves around the Sun in a period of 1 year, and the radius of the orbit is 1.5 multiplied by 10 power 11 meters. Calculate the mass of the Sun. First, list the information and remember to convert the unit of time into seconds. Then, use the formula for calculating the mass of the Earth. N equals to 4 pi squared r cubed over gt squared. Lastly, you will get the mass of the Sun equal to 2.0 multiplied by 10 power 30 kg. That's all. Thanks for watching.